Hey, I'm going to show you guys how to set up a DSG1611 gauge from Altronic for the purpose of controlling auto speed to a CAT engine based on suction pressure. And power your unit up. First thing I want you to do is push menu and scroll down to configure. Push enter, and we're going to start with type. And you're going to tell it, there's several options to choose from right here, but I want you to tell it pressure. And you can just scroll through the menu, and once you find the one that says pressure, push enter again, and it turns your cursor from every time you push enter, when your cursor turns into something like this, up and down arrows, you can change the value. Once you've got the value you want, push enter again, and now your cursor turns into a left to right, and you can scroll down. Use your down arrow button. Push enter again for range, and you want to look at your pressure transducer and find out what range you have. For example, you might have a 0 to 100 or a 0 to 300. This is going to be the last grouping of numbers in the part number on it. So if it ends in 300, it's a 0 to 300. I'm going to set this one up for a 0 to 100 pound gauge. There we go. And then I'm going to move my cursor down one more time, and I'm going to say apply. Enter. It's saved. Now I'm going to push enter again to go to previous menu, and now I'm going to set gauge label. Enter. Now we have a built-in index. What you're going to want is something about 48 or 49. I'm going to use my down arrow button. 49 says suction pressure, 48 just says suction. I prefer 49. Personal preference. Previous menu. Bar graph. There's two things. Current loop actually is what you're telling the thing to do. Bar graph is a visual representation. I like to tell my bar graph and my current loop the same values. So I'm going to go into bar graph first. It's off. I'm going to push my enter button, and I'm going to turn it on. This is a single bar, very hard to see. Here's increasing bars. I like increasing bars. Save. Now I'm going to tell it, I'm going to set this one up, hey, from 25 to operate between 25 and 50 pounds. So I'm going to use my up and down arrows. And the longer you hold it, the faster this goes. $25. And now I'm going to tell this one 50. Now one thing you want to do is don't get caught into anything where you set these values too close together. Example, if say the customer tells you, well, I want it to run dead slow at 25 and dead fast at 26, don't do it, because your engine's going to be racing up and down constantly. You want at least about a 10 psi spread on a 3-stage application. A single-stage application, sometimes up to a 50-pound spread. The idea is to get them to where you're operating, let's say if they're in this application, they could go as high as 70 pounds or 75 pounds on their application, but they, from 50 pounds to 75, they're going to be running wide open. Same thing, 25 pounds down to maybe 20 pounds, they're going to be running dead slow. All right, so I've got 25 for the low, 50 for the high. I'm going to go to previous menu, and now I'm going to go into current loop. Now current loop is the actual meat and potatoes. I got the display value on. If it's not on, you can change that by pushing this button, and you can turn it off or on. I like it on. Now I'm going to set the same values in here. Like I said, the first thing we did, the bar graph, is more visual representation to help you. I like to make sure the bar graph and the current loop both match. Again, it's personal preference. I'm going to back out to previous menu. Back out to previous menu one more time. Now I want you to go into calibrate. With the pressure transducer open to atmosphere, or if you make sure it's absolutely unpressurized, you cannot do a full tweak unless you have a full set of calibration tools and a way to simulate a full range of the pressure. You can do a low tweak. And it's going to ask you set low to calibration and press enter. It's taking a sample. And this one's coming up, it's saying, hey, 12.5, negative 12.5. Yours won't be this far out. I'm using a little potentiometer on this demo here. Then you just simply use your arrow buttons to enter in the value of 0. Enter. Calibration value saved. It's going to exit you out at this point and show that, hey, it's 0. Now at this point, what you can do is you can go and start your engine up and load it. Actually, you could have done doing all this with it unloaded, or with it running and loaded, as long as your switch on your panel was in the manual position. Go and start your engine up, put it in manual, load it up, maybe run it up around 1350 RPM if it's a 3500, for example. And what we're going to do is we're going to go in to tweak the high and low limits on this thing. So we're going to push menu, and I'm going to scroll back down to calibrate, and I'm going to go to loop cal. Now what this means is at 4 milliamps, at a call for 4 milliamps, this is the value it's going to put out. At 20 milliamps, this is the value it's going to put out. These values aren't an industry standard. It's a way for us to take that 20 milliamps and cripple it a little bit, or set limits on it. So an example is, if you've got a 3516 ULB ADEM 3 system set up with the ET software for maximum idle speed at 1400 RPM, that means when you put 20 milliamps to it, it's going to run 1400 RPM. Likewise, if you have it set up for your minimum idle speed to say be like 800 RPM, when we put out 4 milliamps, it's going to run 800 RPM. The problem is with this gauge, we don't want it to run below maybe 1000 RPMs while it's loaded. So what we want to do is we want to set a stop. And some people say, oh, don't run 1400 RPM, run 1350. And it times out. So I'm going to go back into calibrate. I'm going to go into loop cal. Now notice the cursor right here is lined up with this low value, 1304 counts. As soon as you put it there, it's going to override any program that's automatically running in here and drive it to that point. And this is the cool thing about it. So your unit's running, loaded, in manual. Switch it to auto. And at the same time you do this, watch your mids panel screen on the key engine data. You can see the actual RPM and the desired RPM. Now the desired RPM is going to change much faster. So example, let's say your minimum run speed with this gauge, you want it at 1000 RPMs. And it keeps timing me out. I can go back into loop cal. I can line my cursor up there. It's going to be putting out that signal. I can use the switch. It's similar to this. On the panel that says manual and auto, go into auto and watch that desired RPM. If a desired RPM dips down below 1000 RPMs, immediately switch it back into manual and then start adjusting this by pushing enter and changing the value up higher. The longer you hold this, the faster it's going to change. So bring it up if you want the engine to run faster. So I'm going to lock it here and say save, and now switch your engine back into auto. Let's say it stops, the desired RPM stops dropping around 1050 RPM. Hey, I'm good there. Now I can leave it in auto, but I want to tweak it and fine tune it. Maybe I want to drop it down a little bit. So now I just sit there and hold this while I watch my desired and actual RPM. I get it right where I want it, the value, and I push save and I'm done. Now likewise, maybe I want to take it up to check the maximum. I can move my cursor down and do the same thing in reverse. This time I'm watching the maximum speed. So if I'm running 1400 RPM now, I might want to push enter and start dropping this value until I maybe hit 1375 as an example. So I'm in auto, my engine's running, 1400. I start crossing a threshold where it starts dropping. Maybe it drops down to, hey, 1495, 1490. Maybe it's by 1475 by this point, or I'm sorry, 1375. Push enter, and I'm done. At this point, I can exit and go to previous menu, or I can just keep hitting escape, and I'm out. Now I'm going to be up and running. And what you should be seeing remember, we set this one up from 25 to 50 pounds. So I'm putting out 0%, 4 milliamps. We've offset that value to really not let it go below 4 milliamps because we don't want to go to idle speed. Maybe we're limited it to 1,000 RPM. So that's in our sake saying we're running 1,000 RPM. And immediately, as soon as I cross 25 PSI, you see this value changing, you see this bar graph increasing. So likewise, if I get halfway between 25 pounds and 50 pounds, I should be about 50%, and I should be roughly about 12.5 milliamps. There you have it. It's that simple.